Today's lesson is on shortcut electron configurations and valence electrons. And if you did the homework, which watched the video about electron configurations and did the problems, you notice that it takes a long time to write some of these electron configurations. So we want to develop a shortcut method. And then we're going to talk about valence electrons, which is even a shorter method. So great. We talked last time that it would have been really nice and simple if they filled in this order, filling 1s, then the 2s, then the 2p, then the 3s, then the 3p, and the 3d, but we found that was not so. And so to help us memorize where they go or to help us figure out where they go, we're going to use the periodic table, and it will tell us the order of filling if we know the pattern. So we learned the pattern last time, so you can take out your blank periodic table. Hopefully you wrote the pattern down, but the periodic table will give us the pattern. So it tells us that the 1s goes first, then the 2s, then we fill the 2p's, then we fill the 3s's, the 3p's, the 4d's, the 3d's, the 4p's, the 5s's, the 4d's, the 5p's, the 6s's, and oops, then the 4f's, then the 5d's, then the 6p's, then the 7s's, then we do the 5f's, the 6d's, and we're done. All right, so I can use this periodic table and I don't even have to have these numbers on it because I can find these numbers, the 1s and the 3s and the 2s, by the row number they're in, or 1 less than the row number they're in, or 2 less than the row number they're in. So we're going to use this to write an electron configuration for a medium-large atom. And so let's take our periodic table and pick one. Okay. Let's pick iodine. Okay, so iodine's over here, so we want to do the electron configuration of iodine, and we see that it has, although you might not be able to see it, but it has 53 as its atomic number, so if it's neutral, it has 53 electrons. So I need to keep filling in electrons until I get up to 53. And I am in the 1, 2, 3, 4, 5th row. So I'm here, this is where I'm going, right there, right? So how do I do this? Well, I take my periodic table and I just fill it in, knowing that S's can hold 2's, P's can hold 6's, D's can hold 10, and F's can hold 14 if we need to go all the way that far. So let's start. I have 1s2, 1s, then the 2s, 2s2, then 2p6, then 3s comes next, 3s2, 3p6, 3s2, 3p6, then what comes after that? Remember reading left to right. 4s comes next, 4s2, then we drop down to the 3d, 3d10, 4p6, and because it's so long, I'm going to skip down. 5s2, 4d10, and then 5p, and I have to be careful not to go so fast that I just put 5p6 because it's not all the way across, so it doesn't have 6 electrons. It only has 1, 2, 3, 4, 5 electrons in the 5p. And I'm done, and this is iodine. Okay, so I've done this correctly. This is the long way to do this. So what is the shortcut way? So the shortcut way says we're really only concerned usually with the electrons on the very edges of the atoms because those are the electrons that are going to run into other atoms and bond or react. So I really only care about the ones at the very edge, okay? So I'm going to go back to the previous row. This last column, which we're going to learn later, is called the noble gases. So I'm going to go to the previous row, okay? And find out what noble gas was there. So here's iodine. So I'm going to go back to the previous row and see what was the end at the previous row, and it was krypton. So I'm going to write this as krypton. So basically I'm saying it has all the electrons that krypton has plus these. So krypton was right here. So it has all the electrons for krypton plus this row, plus the 5s2, the 4d10, and the 5p5. Okay. So this is the long version. This is the short version. So you go back a row to the very end. So it's like krypton, which happens to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. That's krypton. So it has all those electrons plus 5s2, 4d10, 5p5. That's the long version. That's the short version. And you probably like the short version. All right. Then there's even a shorter version called the valence electrons. Those are really the most reactive ones. So the valence electrons are the ones in the highest number energy level. So let's look at ours here. And we have 5 S's, 4 D's, 5 P's. So it's one with the highest number. Well, the highest number here is 5. So the valence, which we'll learn is the most reactive ones, is 5s2 and 5p5. So this is the long version. This is the shortcut version. This is the valence electron configuration. And one more shortcut, it might say how many electrons are in the valence configuration. And we have 5, 6, 7. 7 electrons in the valence configuration. So long, short, valence configuration, and number of valence electrons. All right, let's try another one, and then you can try some on your own. So let's pick another element. Oh, and let's really go crazy here. So we're going to go France. Oh, let's do radium right here. So let's do radium. And do the electron configurations for that. That has 88, so the long version is going to be so very long. Okay, so let's do the long version and stay with it. It goes all the way to here, right here. So let's do the long version. So I have to fill in all these, so follow with me. It's 1s2, then it fills the 2 s's, then the 2 p's, then the 3 s's, then the 3 p's, then the 4 s's, then the 3 d's, then the 4 p's, then the 5 s's, then the 4 d's, then the 5 p's, then the 6 s's. Ooh, and then there's a star, so it goes down to here, the 4 f's, then the 4, oops, I was not even showing you what I was doing it. 4f14, then back up, then the 5d10, then the 6p6, and then 7s2. Wow. Crazy, crazy long version. Okay? So we don't want to do that anymore. So let's do the shortcut version, which goes back to the previous row, the end of the previous row. So what element is at the end of the previous row? So let's go back. The previous row, what's at the end? Radon. Rn is radon. So I put a little box. So it has all these electrons. These are all the radon electrons plus 7s2. Shortcut version even fun. Okay. Then I go to the valence. So this is a shortcut. Then what about the valence? The valence is just the 7s2. I can forget about all the radon ones. What is in this row? 7s2. Okay, and then how many electrons are valence electrons? There are 2, because there's this superscript that's 2. So this is long for radon. This is the shortcut electron configuration. Not sorry for radon. This was radium. This is the shortcut for radium. This is the valence electron configuration, and this is the number of valence electrons. Okay, and we're going to talk about the significance of these and when we talk about bonding. So these are going to be very important factors. All right, so long, short, valence, number of valence electrons. All right, so hope you get that and give that a try.